Greetings to every one of you. So in this video, we are going to discuss another important concept from operating system, that is Banker's algorithm. It is a resource allocation and deadlock avoidance algorithm. So deadlock is a situation in which two or more processes blocked in unknowingly waiting for unavailable resources. So deadlock can be, that is, avoided with the help of the Banker's algorithm. It consists of two states, namely safe state and unsafe state. The state of the system, it represents the current allocation of resources to the processes. If we allocate the resources with the help of the safe state, definitely we can avoid the deadlock. If we don't follow the safe state, if we follow the unsafe state, definitely it results in deadlock. So, a safe state is one which at least one sequence of resource allocation to the processes that does not result in deadlock. So unsafe state is, of course, a state that will definitely result in deadlock. So this algorithm, it consists of four different the arrays we are going to, that is, use. How many instances of each resource maximum required by the process? It is a two-dimensional array. We are maintaining this. How many instances of each resource currently allocated to the process? Namely, that is allocation. It is also a 2D array. How many instances of each resource is currently available? So the fourth one is how many instances of resources are needed by the process to complete the process fully. So these are, that is a matrix, it is named balance need matrix. Here the problem is given, the two things are given. So we have 5 processes and they need number of the resources, maximum number of resources required by process 1. It is 7, resource 1 7, resource 2 5, resource 3 3. Similarly, for P2 it is maximum required instances are 3 2 2. Similarly, for P3 it is 9 0 2. For P4 it is 4 2 2. For P5 it is 5 3 3. This is the allocated resources. So for P1, that is resource 1 is not allocated. Resource 2 is allocated. One instance of resource 2 is allocated for P1. Similarly for resource 3, nothing is allocated. Similarly for P2, 2 instances of resource 1 allocated. Similarly, resource 2 and resource 3 are not allocated. Similarly for P3, 3 instances of resource 1 allocated and no instances of R2 allocated and 2 instances of resource 3 allocated. Similarly for P4, it is resource 1, that is 2 instances, resource 2, that is 1 instance, and resource 3, that is 1 instance. For P5, that is resource 1 and resource 2 are not allocated and 2 instances of resource 3 it is allocated. So this is the maximum required value and this is the allocated value. So now we have to find out the balance. So the balance matrix we have to calculate. Okay. So just subtract this value from this value so that we can find out the balance need matrix. So the balanced need matrix can be calculated just by subtracting the allocated value from the required maximum value. Okay. So this is maximum that is required, and from this just to subtract the allocated value. So that is 7 minus 0, it is 7. Similarly 5 minus 1, it is 4. 3 minus 0, it is 3. We have to subtract the corresponding resources. Okay, resource 1 with resource 1. Okay, so similarly this is 3 minus 2, it is 1. Similarly this is 2 minus 0, 2. Again it is 2 minus 0, that is 2. Similarly this is 9 minus 3, it is 6. 0 minus 0, that is 0. 2 minus 2, that is 0. Similarly 4 minus 2, it is 2. 2 minus 1, it is 1. 2 minus 1, again it is also 1. 5 minus 0, it is 5. 3 minus 0, it is 3. 3 minus 2, it is 1. So this is the balance, that is what actually processes require the resources in order to complete fully. Now if you find out the total, that is the resource 1 allocated for the different processes. So 5 plus 2, that is 7. And similarly here, that is resource 2 that is allocated for the different processes, that is 2. Resource 3, it is 5. So now the total value, the total resources that is available values are, that is 10 discs and 5 printers, 7 magnetic tapes. So this is our resource 1, it is disc. Resource 2, it is printers. Resource 3, they are magnetic tapes. So now subtract this value from here, the total values, and we are subtracting this allocated value. So now we got the value, that is 3, and this is 3, and this is 2. Now resource 1 available in hand, it is 3. Resource 2, it is 3, and resource 3, it is 2. Now we have to allocate these resources to any one of this process. We have to check. Suppose if I select the process 1, so this is process 1, process 2, this is process 3, process 4, this is process 5. If I select this particular process, that is process 1, which required 7 instances of resource 1, 4 instances of resource 2, and 3 instances of resource 3. But we have only, that is 3, 3, 2, so we cannot allocate these resources to this process. Okay, so now we move on to the next process. Next process is P2, which require, that is 1 instance of resource 1, but here we have 3, so we can allocate. Similarly, resource 2, which require only 2 instances, but again we have 3 instances of resource 2 available, so that is also we can provide. Similarly, the last one, it is resource 3, which require only 2 instances. Again, very well, we have 3, that is 2 instances of resource 3. So now we can provide these available resources to process 2, so that the process 2 can complete its processing fully. Okay, so now first we allocate the remaining resources to the process 2. Consider this is 1. So after allocation of the process 2, so what will happen? The process 2 will be get eliminated. Okay, so originally, so 2 instances of resource 1 can be reclaimed. So that value we can add it here, that is 2 plus 0 plus 0. If you add, now the currently available instance of our resources, it is increased to 5, 3, 2. Understand what actually I am doing? After completion of process 2, it is totally, what is that? The resources can be reclaimed by the operating system. So 2 instances of resource 1, it is added with the available instances of the resources. Okay, 2 instances of resource 1, it is added with resource 1 here. Okay, so now we have 5, 3, 2. After finishing this, now we move on to the next resource, that is next process, that is P3. P3 require, that is 6 instances of resource 1, but we have only 5 here. So we cannot provide the resources to the process P3. So move on to the next process, P4. P4 require only 2 instances of resource 1 and 1 instances of resource 2 and resource 3. So very well we can provide the resource. Okay. So now we can provide the resource to this P4. So the second the resource, I mean the process, it is P4. So P4 we are providing. So now P4 is over. Now after completion of P4, we can reclaim the resources of P4. So what are the resources of P4? That is 2, 1, 1. So add these values with the current available value. 2 instances of resource 1, 1 instances of resource 2 and resource 3. Okay, so that now the available value, the available instances have become 7, 4, 3. Just to add this value. After completion, we reclaimed all these resources. Now just add these values. It is 7, 4, 3. Okay. So now move on to the next process, that is P5. So P5 require 5 instances of resource 1, 3 instances of resource 2 and 1 instance of resource 3. 5, 3, 1. Now available is 7, 4, 3. So very well we can provide. So process P5 can be executed next. After completion of P5, so all these the instance of resources will be reclaimed, so that add this value with the currently available resources. So 0, 0, 2, now the value becomes 7, 4, it is 5. Okay. Now after completion of that one cycle is over, now just move on to, it start from the top. So now the process, that is P1, it is still not yet completed. So which require, there is 7 instances of resource 1, 4 instances of resource 2 and 3 instances of resource 3. Now the available value, it is 7, 4, 5. So very well we can provide the resource to this process 1, so that the process 1 can complete. Okay. So this is 3, this is 4. Okay. After completion of process 1, so how many there is instances are there? Just add those values here. 0, 1, 0. So now we will get the value, that is 7, this is 5 and this is 5. Now available resources are 7, 5, 5. After completion, finally we have only one process yet to complete, that is P3. Okay. So the available instances of the resources are 7, 5, 5. So very well we can provide this resources to P3. So now P3 it is over. So finally this is the fifth one. P3 is over. So after completion of P3, now we have to add these values with the final, the resources. Okay, this is 3, this is 0 and this is 2. So now the result is 10 and this is 5 and this is 7. So which is the total number of resources that is available, 10, 5 and 7. So After P5 we complete, that is P1. After P1, that is finally P3 is completed. So which is the sequence of the save state? If you follow the sequence, there is no chance of getting the deadlock. So this is the result what actually we are producing through this algorithm. Okay. So if you follow that is the unsafe state, definitely will result in deadlock. So in this video we have discussed what is deadlock and how this Banker's algorithm works, and also I explain with the help of an example. Keep watching. Thank you.